Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to differential equation, linear differential equation of the second degree, solved by known integral method. 1 minus x d2y over dx square plus x dy over dx minus y is equal to 1 minus x whole square. In its solution, you should write this equation here, and after that divide the coefficient of d2y over dx square means 1 minus x square. So I write dividing y 1 minus x whole equation, we get d2y over dx square plus x upon 1 minus x dy over dx minus minus 1 upon 1 minus x. Why? Because coefficient of y is equal to minus 1 here, is equal to, when this divided by 1 minus x, we get 1 minus x on the right hand side. This I did it equation number 1 and compare this equation with the standard equation of the second degree. We get p is equal to, which is coefficient of dy over dx, x upon 1 minus x, and q, which is coefficient of y, minus 1 upon 1 minus x, and r is equal to 1 minus x. Here it will not use anyway. Clearly on seeing these two, we see that p plus qx is equal to, p is x upon 1 minus x, and q is equal to minus 1 upon 1 minus x multiplied by x. These are equals, but different signs, so cancel out both. Result is 0. So p plus qx is equal to 0. Hence we can say that y is equal to x is a solution of the equation, given equation, differential equation. Or we can also say that y is equal to x is a part of complementary function. Thus substituting y is equal to vx, so that, because when we put y is equal to vx, x from here, because we know that solution of differential equation u into v, value of u is equal to x, which is known as known integral, which is the x here, and we have to find by putting this value in equation number 1. But when we go to put, we see that here present term dy over dx and d2y over dx square. So we have to find these value first, so that we find dy over dx, differentiated first function and second function. We consider x as first function, so write x first function as a differentiation of second, plus second function as a differentiation of first. Differentiation of x with respect to x is equal to 1. Next we have to find d2y over dx square. On differentiating this, same rule, first function as a differentiation of second, plus second function as it differentiation of first. This is differentiation of this quantity, first term. On differentiating v with respect to x, we get dv over dx. Now we are saying these two terms are like terms, so we can add up these two terms and we get x d2v over dx square plus 2 times dv over dx. Adding these two, this is value of d2v over dx square. Putting these value of y dy over dx, d2y over dx in equation 1, then we will get the reduced equation. So I write here next page, equation 1 reduces to, on putting the value of d2y over dx square, we get x d2v over dx square plus 2 dv over dx. This value I have obtained previous steps. Next term, you can see equation number 1, x upon 1 minus x, and put the value of dy over dx, which is equal to x dv over dx plus 1 minus next term 1 upon 1 minus x, and value of y is equal to bx on right hand side, which is equal to 1 minus x. Opening this bracket, we get x d2v over dx square, and coefficient of dv over dx, I want to collect coefficient of dv over dx. In this term, the coefficient of dv over dx is 2, and on opening this bracket, this term multiplied to both the term. When multiply this to this term, we get x coefficient of dv over dx equal to x square upon 1 minus x. This is coefficient of dv over dx. Now we have to find coefficient of sorry, this is this term is v. You have noticed this. On multiplying this to v, we get the coefficient of v is x upon 1 minus x, and here also coefficient of v equal to minus x into 1 is x upon 1 minus x. This is coefficient of v. Right hand side equal to 1 minus x. These terms are positive and negative, so cancel out, and the coefficient v is equal to 0. So this term is 0. Only these two terms we have to write. X d2v over dx square plus 2 plus x square upon 1 minus x dv over dx is equal to 1 minus x. If we let, for solving this differential equation, easily let dv over dx equal to any variable p. On differentiating this equation with respect to x, we get d2v over dx square and dp over dx. Now putting these value in last differential equation, we get simpler differential equation. This value equal to dp over dx plus 2 x square upon 1 minus x p is equal to 1 minus x. Now changing it into a standard linear differential equation, we have to divide this equation by x. We get dp over dx is plus, when divide the whole this value with the x, we get 2 upon x plus on dividing this value with x, and slot only one power here upon 1 minus x, which is already present. This is coefficient of p. On dividing right hand side, we get, on dividing 1 we get 1 upon x, and dividing x with respect to x we get minus 1. This is linear differential equation. We know that linear differential equation in this standard form, dy over dx plus py is equal to q. This is for reminder. First of all, we should find the value of integrating factor, which is e to the power p dx. Here x is independent variable, which is also in our differential equation, and dependent variable is y, but in our equation dependent variable is p. After finding the value of integrating factor, we can find this solution of differential equation y. This equation, independent variable multiplied to integrating factor is equal to q into integrating factor dx independent variable plus constant of integration. I have to use this formula. So first of all, we collect the value of p, which is equal to coefficient of small p, which is equal to this value. Since y here y is dependent variable, but here in our case small p is a dependent variable, so coefficient of p is capital P, so that I can find the integrating factor by applying this formula. Integrating factor is equal to e to the power p dx. P I have already say this value, which is equal to 2 upon x plus x upon 1 minus x. Integrate it, and term by term we get integration of 2 upon x plus integration of this x upon 1 minus x dx. We can consider 2 as 2 into 1 and take out 2 from sign of integration. Only we get 1 upon x dx. And also this is these terms are in the power of e. I want to change x as a positive, so I take out minus 1 from denominator y. So the sign of this convert to plus to minus, so we get x upon x minus 1. I do it because degree of numerator and denominator is same, so we should divide, and there are two methods of division. So I divide it by inspection method. So I want to convert numerator as denominator form. So since x is positive, so I convert it also positive. E to the power 2 1 upon x, integration of 1 upon x is equal to log x, minus we want to convert numerator as denominator, so I subtract minus 1 in numerator x. Since I add subtract, so I must add 1 here, so that there will not effect on numerator, because here numerator is x. On cancelling out 1 we get on x, which is equal to this, and write denominator as what we see that here this is matched to this term, and it will help us in dividing term by term. On applying the rule of log, we should take 2 in the degree of power of x, so we which is 2 multiply to log, so I take to it degree of means power of x. So integrating factor becomes, I write in next page, e to the power log x square minus and sign of integration, and divide term by term, this upon this plus this upon this. So I can write it as x minus 1 upon x minus 1 and also plus 1 upon x minus 1 dx. E to the power log x square minus, this is cancel out and equal to 1 plus 1 upon x minus 1 dx. Now integrate term by term by applying the linear property of integration. So integrate 1 with respect to x. When opening this bracket, then this sign convert plus sign to minus, and integration of 1 upon x minus 1. We know that integration of 1 equal to x with respect to x, and also we can apply formula 1 upon integration of 1 upon x equal to log x. Because constant is subtract here minus 1, so we can also apply same formula 1 upon x, integration of 1 upon x is log x, but here it is not x but is x minus 1. Only we should think power should be 1 and coefficient, any coefficient should be divide. Since coefficient of x here 1, so we not necessary to divide whole value to 1. If it present coefficient 2 here, so we divide it whole value, whole log equal to 2. But it is here no 1, so no necessary to divide. These are 2 logs, so I write as I want to combine it. We according to log formula, we write only 1 times log, and the value, positive value should be in numerator and negative value should be in denominator, and this value, after this value minus x, I write minus x here. We can separate this value as e to the power this value log x square upon x minus 1, and also into e to the power minus x, because base is same. If we write to combine it, so write e and add up these terms, we get this value, so we can write this as, because e to the power log, so we can we know that e to the power log is cancel out, only this value is remain, x square upon x minus 1 multiplied by e to the power minus x. It is value of integrating factor. Now we should apply this formula, but here y is replaced by dependent variable p. So solution of differential equation 2 is, therefore solution of differential equation 2 is given by p into integrating factor according to formula q. Here q is value of right hand side, which is equal to 1 minus x 1 minus 1 upon x minus 1, sorry, and integrating factor I will write in next step. Since here we have to add 2 constant, so I write first constant c1 and next c2. You can write any alphabet a, b or c1 c2. I write c1 c2. Now I will put the value of integrating factor x square upon x minus 1 e to the power minus x, and also I will take LCM 1 and x equal to x. So 1 multiplied to 1 and x multiplied to 1 becomes minus x. Integrating factor is value is x square upon x minus 1 into e to the power minus x dx plus c1. The value 1 power of x cancel out by this, only x 1 value power of x equal to 1, and on taking out minus 1 from this bracket, then x become positive and 1 become negative, and x upon x minus 1. I do this because this factor will cancel out, only we have to integrate only this value, which I write as x e to the power minus x dx plus c1. We have to integrate this value by integration. I write left hand side without any change. Integration by parts. We can apply first function. Consider x as a first function and e to the power minus x is second function, and apply this formula. Integration of first and second is equal to first function as it integration of second minus differentiation of first function integration of second function, and after that integrate whole value. I apply this formula on the next page and write this value as it without any change. P into P into x square upon x minus 1 e to the power minus x is equal to minus integrate by applying this formula into first function as it integration of second, which is equal to minus x upon e power x integration of e power x equal to e power x. What it is not e power x, it is minus x. So divide by its coefficient, means coefficient of x, which is equal to minus 1, minus applying that formula differentiation of first function, which is equal to x, differentiation of x equal to 1, integration of second function is here. So I write this value again, e power minus x upon minus 1, and integrate whole value, means first differentiation first and integration of second, and after that I write constant c1 minus is we write here x e to the power minus x. This minus convert this to plus what, integration of e to the power minus a second e to the power minus x upon minus 1 plus a constant of c1, and now we should put the value of p, which is equal to dv over dx, x square upon x minus 1 e to the power minus x, and minus on multiplying this value, take out minus 1 and convert this value to plus, and also we can take e to the power minus x constant, only we get x plus 1, because minus convert these to minus with plus c1, which is simplest form. And after that I will find the value of dv over dx by transposing this term to right hand side. So e to the power minus x plus 1 multiplied by x minus 1 and divided by x square e to the power minus x. Also this term multiplied by x minus 1 and divided by x square e to the power minus x. Here e to the power minus x, x square cancel out by this, and we get dv over dx is equal to x square minus 1 square, which is equal to 1 upon x square, on solving this by applying formula a square minus b square plus c1 x minus 1 upon x square, and take it to numerator, then the degree of this become positive. We have to find the value of v, which is all terms in x, so we can easily separate two variables, terms of x one side and terms of v other side, and dv and dx should be in numerator. What we see that there are no other term v, so this value is x square minus 1 upon x square and plus c1 x minus 1 upon x square e to the power x dx. And on integration we get on integration we can consider 1 here, so integrate 1 with respect to v, and this term integrate first term integrate with respect to x, and also I apply here linear property of integration, so constant is taken out from integration, we get x minus 1 upon x square e to the power x dx. Integration of 1 with respect to v is v equal to we can write it as on dividing x square by x square minus 1 upon x square plus c1 x divided by x square minus 1 divided by x square e to the power x dx. X square is cancelled out by 1 by x square, then we get 1 minus 1 upon x square. We have to integrate it. Here we can consider it as on dividing x by x square we get 1 upon x here, and plus we can write it as 1 upon x square because this is a derivative of this function, and we can apply a special formula for this. We know that I will explain here. We know that integration of fx and derivative of fx, which is plus to this value, and multiply to e to the power x. We know that this formula integration of this value is e to the power x fx. We can easily find this value. What I apply this formula just here without calculating it. V is equal to, you can calculate it, remain this function on multiplying this function as it, and integrate its integration by part, then we see you will find this value easily. If any problem you can contact me. Integration of 1 with respect to x, and also integration of 1 upon x square with respect to x, plus I apply this formula here, so the integration as is e to the power x into 1 upon x. What when we integrate, we should constant of integration here because our differential equation is second order, so in its general solution it will have it must have two arbitrary constant which is present here. Integration of 1 with respect to x is equal to x minus integration of for integration of x square we take x square in numerator, this become x to the power minus 2 plus c1 c1 e to the power x upon x plus c2. V is equal to x minus integration of this, we know that power is one power is add to this and also this value divided by this, which is according to formula, as you know, e to the power x upon x plus c2. V is equal to x minus x to the power minus 1 upon minus 1 plus c1 e to the power x upon x plus c2. This minus 1 turn this minus 1 plus, so we find x plus x to the power minus 1 plus c1 e to the power x upon x plus c2. You can change as 1 upon x plus c1 e to the power x upon x plus c2. Now we are able to find the general solution of given differential equation. So therefore the required solution is y is equal to vx, which I put this value y is equal to vx. We consider v is equal to vx is a solution, so put the value of v as x plus 1 upon x plus c1 e to the power x upon x plus c2 multiplied by x. On opening this bracket, x multiplied to x become x square and 1 upon x multiplied to x, also c1 e to the power x upon x multiplied to x and c2 multiplied by x. Cancel out x to x, we get y is equal to x square plus 1, and also this cancel out, we can write c1 e to the power x plus c2x. This is the required solution. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.